Hello, boys and girls. Today we're going to read Listening to Earth for Amplify Science. Just a friendly reminder, as we're reading and listening, you are an active listener and making all of the annotations to deepen our understanding. Here we go. Paragraph 1. Bob Ziak studies plate boundaries in a surprising way. He listens to them. Ziak is a scientist who works for the National Oceanic and Atmospheric Administration, NOAA, a government department that studies the ocean and the atmosphere. Ziak and his team wanted to know more about what happens on the ocean floor, especially at plate boundaries. Sending people to the bottom of the ocean is difficult, so Ziak and his team use hydrophones, powerful microphones that are built to travel deep underwater. The team sent hydrophones 10.99 kilometers, 6.83 miles, down into the deepest place in the ocean, an area known as Challenger Deep. Challenger Deep is an underwater canyon, part of a larger landform called the Mariana Trench. Ziak and his team didn't expect to hear very much noise so deep below the ocean's surface. What they actually found surprised them. Their hydrophones picked up sounds from many different sources. One type of sound collected by Ziak and his team was the sound of plate motion in the form of earthquakes. Earthquakes happen at plate boundaries all over the world. They are caused by the motion of plates. Ziak travels all over the world studying plate boundaries under the ocean and using hydrophones to collect data about the earthquakes that happen there. By recording earthquakes at different plate boundaries, Ziak and his team are using sound to study the way that plates move on Earth. Listening to convergent boundaries. The Mariana Trench lies on a convergent boundary. In fact, the trench is a convergent boundary, formed by one plate sinking under another. Since the plate boundaries tend to have a lot of earthquakes, Ziak and his team weren't surprised to hear some earthquakes on the recordings. However, they heard many more earthquakes than they had expected. Ziak explained that when they recorded sounds from Challenger Deep, there was even more earthquakes than we thought there would be. Our recordings taught us that plate motion is always moving along. Paragraph 4. At convergent boundaries, two plates are moving toward each other. When the two plates collide or run into each other, one is forced underneath the other. This collision is very slow, but the forces that cause it are very strong and affect both plates. Over long periods of time, the plate that is on top can bend and fold. The plate on the bottom is shoved into the mantle, bending downward and forming a deep trench at the boundary. As the top of the plate sinks into the mantle, it is destroyed and becomes part of the mantle. Both earthquakes and volcanic activity are common at convergent boundaries. Listening to divergent boundaries. Paragraph 5. Bob Ziak and his team don't just listen to ocean near convergent boundaries, they also use their hydrophones to listen in on divergent boundaries. Divergent boundaries are the opposite of convergent boundaries. They are places where two plates are moving from each other. As the plate moves, hot material from the mantle comes up to fill the space between them. The hot mantle material cools and hardens and adds new rock to the edge of each plate. Over time, these additions of rock form a mountain range made up of a long chain of volcanoes. When this process happens on the ocean floor, scientists call the landform a mid-ocean ridge. Mid-ocean ridges can be thousands of kilometers long. Paragraph 6. By listening to the ocean around divergent boundaries, Ziak and his team can detect earthquakes and volcanic eruptions that humans wouldn't know about in any other way. After all, mid-ocean ridges are deep underneath the ocean's surface and may also be thousands of kilometers from land where people can easily observe them. By lowering a hydrophone into the water near a mid-ocean ridge and letting it record for a long time, Ziak and his team can hear how many earthquakes and volcanic eruptions are taking place. Ziak uses hydrophones to study the smaller earthquakes called foreshocks that occur at divergent boundaries before major earthquakes. Big earthquakes at divergent boundaries have a clear pattern of foreshocks, he says. It's not something you see on land, and we're finding this pattern at divergent boundaries all over the world. Ziak believes studying earthquakes in the middle of the ocean may help scientists refine the tools they use to study earthquakes on land. If earthquakes had this kind of predictability on land, it might be something we could use later on, he says. 5 in the morning. Putting it all together. By studying both convergent and divergent plate boundaries, Ziak is studying the ways that plates move all over our planet. In some places, the motion of the Earth's plates work like a conveyor belt. Most plates have a convergent boundary on one side and a divergent boundary on the other. On the side with the convergent boundary, plate material is sinking into the mantle and being destroyed. On the side with the divergent boundary, new plate material is being made at the ocean ridge. The motion takes place at a rate only of centimeters per year, but since one side of the plate is being destroyed and the other keeps getting new plate material, they keep moving. Ziak's research is helping us to understand more about how plate motion happens. We just have to listen.